In this section, we will explore container registry-based attacks. A registry is a place where you can store and retrieve Docker images. Docker supports both public and private registries. Organizations usually have their private registries on-premise or on the cloud. AWS, GCP, and Azure have their own managed registry services. You need to log in to push or pull images from private repositories, as shown in the slide using the docker login command. An example of a public registry is hub.docker.com. Many organizations prefer to use in-house Docker registries. In-house Docker registries can be managed on an independent machine, or in-house registries can also be managed through unified product offerings such as GitLab that not only helps build images, but also has registry in itself to store and manage images. Docker registry is available as a container with a name registry. All the big three cloud providers such as AWS, GCP, and Azure also offer their own flavor of public, private, shared registries. Docker registry is very easy to set up, but low cost of easily starting up a registry results in higher costs of managing the registry securely. Think about configuring a web application. We need TLS, we need identity and access management, authentication, authorization. Similarly, a Docker registry needs to have TLS to reap the security benefits of transport layer security, authentication, so only users that are explicitly allowed can use the registry, authorization, so only users with push privileges can push images, and users with sign privileges can sign an image for added trust. Continuous scanning procedures, so images are scanned for vulnerabilities. Procedures to push images, such as images, are only allowed to be built on a CI/CD server after a peer review of a Docker file, and only the CI/CD server has permissions to push images to a registry. Firewall or IP whitelisting rules, or VPN, to explicitly allow connections from trusted IP addresses. A report by Palo Alto in the year 2020 revealed about 1,000 registries publicly exposed to the internet, among which 100 of them did not have any authentication. That's only a tip of the iceberg. Think about the about of repositories and images in each of these insecure registries. Were they supposed to be exposed publicly in the first place? I hope you have enjoyed this lecture. See you in the next lecture.